In this video, I'm going to crash all 4 terrestrial planets into Earth, starting with Mercury, then Mars, Venus, and finally another Earth. We'll see what happens from the planet's surface all the way to its orbit. First, let's send Mercury crashing into Earth. In this simulation, Mercury approaches Earth with an initial impact velocity of about 3.51 kilometers per second. The collision releases an astonishing 2.03 nonillion joules of energy. Temperatures at the impact site immediately soar to around 4,500 degrees Celsius. The intense heat rapidly spreads across the entire planet, turning much of Earth's surface into a global ocean of molten rock. Some of the debris launched into space eventually falls back, creating a deadly storm of secondary meteor impacts around the globe. Earth's average surface temperature climbs to over 3,900 degrees Celsius. After the impact, Earth's mass increases to about 1.02 Earth masses, while its overall radius remains nearly unchanged. Meanwhile, about 0.035 Earth masses of material are blasted into space as debris. Let's speed up time and watch Earth slowly recover from the collision. As the planet cools, liquid water gradually returns and once again covers Earth's surface. I'll also redistribute the oceans evenly to make the changes easier to observe. Since the impact occurred over the Americas, the entire continent is completely erased. Europe also disappears beneath the aftermath of the collision. Large portions of Africa are gone as well. Earth's rotational axis is no longer aligned with its original poles and has shifted several degrees. The impact speeds up Earth's rotation, shortening a day to just 20.7 hours. The Moon's orbit is also affected, increasing its orbital period to about 28 to 29 days. Earth's orbit around the Sun changes as well, with its semi-major axis shrinking by about 0.01 astronomical units. As a result, 1 year on Earth now lasts only about 11.8 to 11.9 months. Next, let's crash Mars into Earth using the same impact speed of 3.51 kilometers per second. Even before the collision begins, Mars' gravity starts pulling Earth's oceans toward it, causing seawater to flood across nearby continents. Since Mars is about twice as massive as Mercury, this impact releases significantly more energy. The collision unleashes an incredible 944 trillion megatons of TNT. Temperatures at the impact site immediately rise to over 5,000 degrees Celsius. After the collision, the merged planet reaches a mass of approximately 1.05 Earth masses. Around 0.057 Earth masses of material are blasted into space, while Earth's radius expands by roughly 2%. Let's fast forward and wait for Earth's surface to cool down once again. Because the impact strikes Asia, the continent is completely wiped out. Europe is also erased by the aftermath of the collision. North and South America remain largely intact, while most of Africa disappears. Parts of Australia are destroyed, but Antarctica survives the impact. Earth's South Pole shifts to a position near Australia, while the North Pole moves close to Africa. The planet now spins in a rolling motion, completing one full rotation in just 15.2 hours. As time passes, ice rapidly spreads across both the continents and the oceans, covering much of the planet's surface. Earth's average temperature eventually drops to around -10 degrees Celsius. Despite these dramatic changes, the atmosphere remains surprisingly similar to its original composition. Earth still retains a habitability rating of about 83%. The Moon's orbital period increases to approximately 30 to 31 days. Earth's orbit around the Sun also shrinks slightly, reducing its semi-major axis. As a result, one Earth year now lasts only about 11.7 months. Next, it's Venus' turn to collide with Earth. Just like before, the impact speed is set to 3.41 kilometers per second. Even before the collision, Venus' much stronger gravity pulls Earth's oceans so intensely that seawater floods across an entire continent. This impact releases an incredible 7.16 quadrillion megatons of TNT. Earth's average surface temperature instantly rises beyond 5,000 degrees Celsius. The merged planet now has a mass of approximately 1.61 Earth masses. At the same time, about 0.205 Earth masses are ejected into space as debris, while Earth's radius increases by roughly 15%. Let's fast forward and see whether Earth can become habitable again. This time, the planet never cools down. The average surface temperature stabilizes at around 700 degrees Celsius, preventing liquid water from ever returning. Even more dramatically, the atmosphere becomes 100% carbon dioxide. Earth's rotation axis shifts, placing the South Pole near Southeast Asia and the North Pole near South America. The planet now spins in a rolling motion, completing one full rotation in just 4.5 hours. The collision also has a dramatic effect on the Moon. The Moon escapes Earth's gravity entirely and begins orbiting the Sun instead. Earth's orbit changes dramatically as well. Its semi-major axis shrinks by nearly 10%, shortening Earth's orbital period to just 10.6 months. Finally, let's see what happens when Earth collides with another Earth. Just like the previous simulations, the impact speed is set to 3.41 kilometers per second. This collision releases an unimaginable 8.79 quadrillion megatons of TNT. Instead of both planets shattering apart, the Earth being struck is completely engulfed by the incoming Earth. Temperatures across the planet soar to well above 5,000 degrees Celsius. The merger creates a new planet with a mass of approximately 1.71 Earth masses. During the impact, about 0.29 Earth masses are blasted into space as debris. Let's speed up time and see how this new world evolves. Because the rotation axis has shifted close to the equator and the planet now spins incredibly fast, completing one rotation in just 4 hours. The oceans migrate into a massive belt stretching from the North Pole to the South Pole. The planet also rolls as it rotates, making the cycle of day and night highly unpredictable. At certain moments, the rotation axis points directly toward the Sun, causing parts of the planet to experience neither a normal sunrise nor a sunset. Earth's atmosphere is transformed as well. It is now dominated by water vapor instead of the gases we are familiar with today. The collision ultimately separates Earth and the Moon, sending the Moon onto its own independent path. Earth's new orbit has a semi-major axis of about 0.920 astronomical units. As a result, Earth now completes one orbit around the Sun in only 10.6 months. So, which collision surprised you the most? Was it Mercury, Mars, Venus, or even Earth itself? Let me know your thoughts in the comments below. And if you have another space simulation you'd like to see, don't forget to leave your suggestions as well. If you enjoyed this video, make sure to leave a like and subscribe so you won't miss future simulations. Thanks for watching, and I'll see you in the next simulation.